Team, this is lesson 9, unit 6, comparing fractions with the identity property, like numerators. It doesn't always have to be like numerators. You can go denominators if a kid can find them, but it's about the ease of the number. So whichever one's going to make common numerators or denominators faster. So today, tomorrow, and every day, I can compare fractions by creating equivalent fractions with the same numerator, denominator, and then comparing values. First, I ask myself, are my wholes the same size? Then what's the best strategy? Either compare to a half or find equivalent fractions and then ask which is larger, smaller, or greater. This is why the questioning around wholes is so important first. Are the wholes the same size? Honestly, we don't know, but let's pretend like we did, and then we're finding that equivalent fraction. I did not do math here because I was asking myself about wholes. Are my wholes the same size? No, this is a large cup of water and a small cup of water, but this fraction is greater than that fraction, so I guess I could say that this is, this is actually just bad. It's a bad page because I think this, if the pies are the same, this, if the cups are the same, and this, if the cakes are the same, okay. But here, large cup of water, small cup of water, yes, 2/3 is greater than 2/8. So we'll go with a true, but that is really weird. This is the problem that I want you to see. This is very similar to the work that I did yesterday, where first we want a child to say Tanya 8/5/6 and Jaylene 8/10/15. First, are my wholes the same size? Yes. Now, what strategy makes sense? Let's see if we can use number line with halves because it's so fast. Is this greater than, less than, or equal to a whole? Greater than 1/2, sorry. Is this greater than, less than, or equal to 1/2? It is greater than 1/2, so I can't use 1/2 as my metric. So I'm gonna have to roll with equivalent fractions. Is it easier to find an equivalent or common denominator between 6 and 15 or 5 and 10? Man, it would be a lot easier to find a common numerator between 5 and 10. It's literally 10. So just like I did the other day, before I move into, I think about it as a 3-step process, I always am going to create a visual model to just start with so kids get comfortable with this process. And Nicole, this has to be present in yesterday and in today. 6th, 15ths are going to be really hard in just a second. And 15ths, I'll go thirds first to get to 5s. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Need 10 of them. 1, 2, 3, 4, 5. 1, 3, 4, 5. Great. Okay, so I can tell that this one's bigger so far, but I'm not certain. So this is 5. Ooh. Okay, this is 5/6. And this is 10/15. This needs to stay tenths. This needs to go to tenths. So this is going to be 15ths, and I'm just going to break it. Now it's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10/12. And we'll double check down here. 5/6, and 10/15. And it has to be tenths on the top because that's what we agreed to up here. 5 times 2 makes sense. I split it into twice as many parts. 6 times nothing gives me 10/15. And I go back up here. 10/12, which is greater. 10/12 or 10/15. 12 because the pieces are bigger.